Hello everyone, welcome back to another lesson on measurement. Today we are going to be exploring scale factors. Let's have a look at our concept map for today. So everyone, firstly I'm going to talk about what is a scale factor. After that, I'm going to show you what a scale factor would do to a rectangle. We're also going to talk about polyhedrons and we're going to remind ourselves of what those are. Then we're going to have a look at the influence of scale factors on cubes as well as on rectangular prisms. Great, so let's start off with what is a scale factor. It is possible that the dimensions of a prism are changed. For example, the length, breadth, and height of a rectangular prism may be doubled. This would mean that the volume and the surface area of the prism would then change. The number that each dimension is multiplied by is known as the scale factor. So everyone, all this is saying is that in measurements, if I've got a 2D shape or if I have a 3-dimensional shape, I can multiply certain lengths by scale factors. So for instance, if I have a cube that has sides of length 2 and my scale factor is 2, I multiply each side by 2. So I'll have 2 times 2, so the sides of the cube will then be 4. So essentially the scale factor changes the dimensions of a shape through multiplication. Let's look at the next slide. So if I were to use an example of a rectangle and the length is x units and the breadth is y units, then we can write the area of the rectangle as length times breadth. So this is just linking back to some of your previous knowledge that if I have a length of x and a breadth of y, the area of this particular rectangle will be length times breadth, which is just xy. Great. Now I'm going to show you what would happen if I introduced a scale factor to this rectangle. So if we were to decide to now triple the length and the breadth, this means that we would multiply the length and the breadth by a scale factor of 3. So we're tripling the lengths of the rectangle. So we can see that it's now 3x and 3y. So I'm now going to calculate my new area of the rectangle, which has been multiplied by a scale factor of 3. Length times breadth would end up being 3x multiplied by 3y. So my new area would be 9xy. So if I want to look at the comparison between the new area and the old area, the new area divided by the old area would be 9xy divided by xy, which is just going to give me an answer of 9. So I can see that the scale factor of 3 has made the particular area of this rectangle 9 times larger. Great. I hope everyone's with me. So we're now going to look at what would actually happen if I've got different scale factors introduced for this particular rectangle. So just a reminder, I was using the rectangle that had a length of x and a breadth of y. Let's look at our table. So if I said that my scale factor is 4, that means that I'm going to be multiplying the length by 4 and multiplying the breadth by 4. You can see slightly above I've done the scale factor of 2, and I've illustrated that the length and the breadth were each multiplied by 2, which gave me a result of 4xy. But let's see what happens when I multiply by 4. So the length would be 4x, the breadth would be 4y, and the area would be 16xy. Then for the next one, I'm going to have a half multiplied by my length. So it's going to be a half x because my scale factor is a half. Then it's going to be a half y, which is my breadth, and a half x times a half y is going to give me a quarter xy. Then if I look at my length and my breadth, if my scale factor is 100, I'm going to have 100 times x. My breadth will be 100y. And last but not least, my area would be 1000 xy. Cool. But let's see if I can actually make a general rule for this and having a scale factor for a rectangle. If I say kx, because my length has been multiplied by k, and then I move on to my breadth, which will be ky, because I'm multiplying my length and my breadth by a scale factor of k, my area is going to be k squared y. So this lets me make the conclusion that in general, if the length and breadth of a rectangle is multiplied by a scale factor of k, then the area of the rectangle would have been multiplied by k squared. So with these rectangles, you can see that the new area of the rectangle is k squared times the original area. So if I go back to this slide, you can see that the scale factor squared was always making an impact on that actual area. Sorry guys, that should have an xy. I left the x out over there. So we always are going to have the scale factor squared affecting the area of this particular rectangle. Cool. Everyone, let's move on. For a cube, we've discussed previously that the volume is the area of the base times the perpendicular height. So the volume of this cube is L cubed. The surface area of a cube is equal to the sum of all the squares that make up this particular cube. And because a cube is made up of squares, we're going to take the area of 6 identical squares, and the area of the squares is L squared because we know that the lengths are all equal amongst this square. So because there's 6 squares with an area of L squared being added together, the surface area is 6L squared. Great, everyone. I hope that you're with me so far. After the break, we're going to be looking at how the scale factor influences three-dimensional figures. See you soon.